Oh, it looks crazy.
All right, so today we're going to be going over the depth function in Qiskit. This function basically returns the longest path in a circuit, but it is tricky to understand on some cases. So what I'm going to do is give a general example and then go on to more complicated examples. So let's start. So what I'm going to do here is write the code down here and then explain how it's drawn and how it's visualized. So let's start. Okay, so this is the first line of code for the first example. So this is saying we're initializing a quantum circuit. We have 2 qubits and 2 classical bits. So this first line is just going to initialize our circuit. So initially what we're going to have is this. So our circuit is going to look like this. So far what we have is an empty circuit. We have 2 qubits right here and then 2 classical bits. This is mainly going to be for measurement. So if I were going to measure it, what would happen is that I would have my measure operations here to transfer the state down into the classical bits. But for this example, we're not doing that. So all we're going to do for this example is just apply our gates and not measure. So there's really no need for the classical bits here, but we're just going to have them there just for the visualization. Second line. So this is the second line. We want to apply a Hadamard gate on the 0th qubit, which is here. So what this is going to do is take this state here, apply Hadamard gate, and then we're just going to keep going from there. So yes, so this is what we're going to do is we apply Hadamard gate here. What happens here is that if I have a 0 state and I apply Hadamard gate to it, it's going to become the superposition state 0 plus 1 over square root 2. If I have 1, it's going to become the superposition state 0 minus 1 over square root 2. And on the Bloch sphere, the 0 state, this is the 1, this is the x, this is the y. Initially, if I have a 0 state here, it's going to rotate to this state here. Okay, so how does it look like? So the Hadamard basically is a y90 rotation followed by an x180 rotation. So this is not necessary for this video, but if you wanted to know, I'm just going to go over what this means. So the y90 is going to take the 0 state, it's going to rotate it pi over 2. So we're going to come here, rotate it we're going to rotate it about the y-axis, and we're going to come to the positive x direction. All right, so you go from 0 to positive x because of the y90. We're rotating this way, right? And since we're already on the x-axis, this stays here. So we're not rotating at all, right? If we were at 0 and we apply the Hadamard, we're going to go here. And opposite direction, if we're at 1, we're going to rotate here. So we're going to do the same thing, but we're going to come here. So the backwards direction, right? So we're going to come to this is the minus x. Cool. Next line is controlled not on 0 to 1. Okay. So I went over this in my first video, so I'm not going to go right now. But basically, you have a 0 on this state here, you leave the state alone. If you have a 1, you flip it. So that's basically the C0. The fourth instruction, or the fourth line of code, is going to be the S gate. So the S gate is a pi over 2 rotation about the z-axis. So what happens is it induces a pi over 2 phase. Okay, so this is the end of the circuit. So what you can do to output this, if you wanted to, is the most simple way is just draw. And then you can put output equals text. So that's a simple way of outputting the circuit. So now the question is, what is the depth? The depth is basically the longest path of the circuit. So how I would do this is basically put your finger here. 1, 2, 3. Simple as that. So this depth is going to be 3. So depth is 3. That's simple. It is 3. Just 3. Okay, now are there any unusual cases of this? Because it's pretty simple, but there are some cases that are important. So simply enough, if I have nothing, so imagine I just had this initially, and I had just a regular, Q0 thing, that depth is 0 because nothing there. In other cases, that if this was just 1 here, so you don't count levels basically. Let's say I had something like this. you wouldn't count this twice, meaning you wouldn't do 1, 2, 3, 4. It would be 1, this level, this column here, 1, 2, 3. So it'd still be 3 because you're not stacking these together. So another important distinction, I guess you could say, is the barrier. So what the barrier does, it's basically a method within Qiskit that allows you to kind of, it tells the transpiler, so the transpiler is basically a whole different topic, which I'll go over later, but the transpiler basically, as executing the instructions, if there's a barrier, it won't simplify the two instructions together. So that's kind of something I'll go over later, but just for visual, so just to visualize it, what would happen is that you would have a the barrier is here. So you may ask yourself, how did I get here? You may ask yourself, as you're counting this, is this going to be added to the count? The answer is no. This is not going to be added to the count. So what you would do is say 1, 2, skip this, and 3. So these are the main kind of things to understand. It's not that complicated, but these are some things that kind of did confuse me initially, so I did want to put this out. So the answer is still 3. And yeah, that's how depth works. I think in the next video, I do plan to go over fidelity. So yeah, this is the depth function. So initially we had 2 qubits and 2 classical bits, Hadamard Gate on the 0, 0, 1, a barrier, which does not add to the count, and the S gate, which does on the 1, so the 1, right, is going to process around the z-axis, pi over 2. So it's going to do a pi over 2 phase. We drew it. Then we output our depth, which is 3. So that is how to use the depth function in Qiskit.